This is a video lesson for section 2.2, the one we just covered today. And 2.2 is all about comparing rational numbers, and rational numbers includes every single number type, but specifically we're interested in the subset of fractions and decimals. So 2.2 is all about comparing two fractions to each other and seeing which one's larger, comparing to decimals, which is typically easy, but also comparing a fraction and a decimal, which is probably the hardest of the three comparison types. So let's take a look at fractions first, and I'm not even going to do decimals because looking at two decimals is fairly easy to tell which one's bigger or not. So let's take a look at two simple decimals, fractions. 2 over 3 and 3 over 5. Now looking at the two, right off the bat, it's kind of hard to tell which one is bigger or not because they have different denominators, and that kind of muddies the field as far as looking at the two and visually being able to interpret which one is the larger. So the best way to deal with a problem like that is to come up with a common denominator for the fractions. Now the easiest way to come up with a common denominator is to multiply the denominators present. If you have two fractions, you just multiply the two denominators present. So we're going to find the common denominator. Alright, and to do that, we're going to go ahead and multiply 3 times 5, the denominator is present, and that of course is 15. So our common denominator for these two, we don't know if this is the smallest that they have in common, but this is a common denominator. This will work for both of them. Well, I do know if this is the smallest or not, but that's not important right now. So now we have to get this denominator for this fraction and the same denominator for this fraction. So I'm going to rewrite 2 over 3 over here. And how do we get the 3 to become into a 15 using multiplication? Well, you multiply it by 5. 3 times 5 is 15. That's perfect. So that's exactly what I'm going to do. I'm going to multiply the denominator by 5. Now in fractions, very much like equations, you can't deal with one side and not deal with the other. So you can't outbalance the fraction. So if you multiply the denominator by 5, you have to multiply the numerator by 5 as well. So you multiply top and bottom by the same number, in this case 5, to get our denominator to be 15. Alright, so that gives us 10 over 15. Perfect. Perfect. So now we're going to take a look at the other fraction. We're going to take a look at the 3 over 5. And how do we get a 5 to become 15? We can multiply it by 3. And just like before, you have to multiply both the numerator and the denominator by the same number in order to keep your fraction numerically the same. That's going to be 9 over 15. Now that you're looking at them in this form, it's easy to tell which one's bigger. The 10 is obviously bigger than the 9 since now they have the same denominator. The only thing that's different is the numerator, and this one wins. This one's bigger, and of course this fraction is numerically the same as this. That means the 2 over 3 is also bigger than the 3 over 5. And that's essentially how you compare two fractions with different denominators. So let's say we have a different problem. Let's say we have let's do another example. Let's say we have 5 over 10, and I'm comparing it to 7 over apologize, 15. Now, you can find a common denominator here as well by simply multiplying 10 and 15. So common denominator, I'm just going to refer to this as a CD. In this case would be 10 times 15, which is 150. That's a large number, and you can make that into your common denominator. It'll work. It's a common denominator. But is there something smaller, something less or easier to deal with smaller numbers? Is there an LCD? And the LCD is called the least common denominator. It's the smallest denominator that the two of them have in common. There might be one for this one. How do we find out? Well, I'm going to take the 10, and I want to go ahead and list all the multiples of 10. Well, of course, there's 10, which is 10 times 1. Then there's 20, which is 10 times 2. Then there's 30, which is 10 times 3. Then there's 40, which is 10 times 4, and so on and so on and so on. And I can go on here. Then I'm going to do the same thing for 15. I'm going to list all the multiples for 15. Obviously 15 itself, 1 times 15. Then 30, 2 times 15. Then 45. I'm going to stop here because I found what I needed to look for. And what I was looking for was this. A number that they have in common. So this is the least common denominator for these two. Just like the 150, it works, but it's a lot smaller. And in math, smaller numbers means easier to deal with problems with less of a chance for you to make a mistake and generally just a happier mathematician. So this is going to be our common denominator. Again, you can work with 150, but why when you have a 30? So once again, I'm going to write up our first fraction, 5 over 10. And I'm going to multiply it by something that's going to get this 10 to become a 30. And yes, you guessed it, it's a 3. And just like before, I have to multiply top and bottom to get, not to unbalance my fraction. And that is, of course, 15 over 30. Then I want to do the same thing with the 7 over 15. And how do I get the 15 to be a 30? I can multiply it by 2. And once again, I do the same thing for top and bottom. And this gives us 14 out of 30. Which one's bigger? Easy. Since they have the same denominator, obviously the 15 is greater than the 14. And since the 15 over 30 is equivalent to the 5 over 10, that means that the 5 over 10 is greater than 7 over 15. And voila, you now have two fractions that didn't look anything alike, and they were really close. So it's not like you could have looked at the two and went, oh yeah, one is definitely bigger than the other one. No, they were pretty close. But once you gave them the same denominator, you could easily tell which one is bigger. And you could have used the 150. It would have worked. You would have to multiply the 10 by 15 and do the same thing with the top, and down here you have to multiply the 15 by 10. Those are big numbers. 30 is so much better. So you find the least common denominator by listing the multiples of both fractions. If there's a third one, you would list the third one as well and look for one that they have in common, but that's a bit more complicated. We're working with just two. You list the multiples, you find the first smallest number that both of them have in common, and that becomes your LCD. So there's going to be a part 2 to this in just a second.